Okay, yeah, I'm back. So today we are discussing the periodic table. The periodic table normally is the first topic in SS2. Conventionally, is the first topic in SS2. But if you have not entered that topic in your school, please don't be scared, don't be perturbed. We are still going to take care of all your topics. Is that clear? So I'm going to share my screen now. I hope you can see my screen, everybody. Can everybody see my screen?
Yes, sir.
Yes, sir.
Good, good. So we are discussing the periodic table, all right? And of course, my name is Celestine Nemeka. I am your chemistry teacher. So let's fire up immediately. The periodic table, of course, you may have heard or you may have seen, is an arrangement of, is an assortment of elements, okay? Is an assortment of elements into vertical columns and horizontal rows. Today, we are going to look at the vertical columns and horizontal rows and begin to have an understanding of what each of these mean. Scientists over centuries have discovered different elements and have made attempts at arranging the elements based on their similar properties. So for today, depending on what the time permits, these are the learning objectives. So I want you to bring out your pen and write. These are the learning objectives. Number one, we'll state or will be able to state the periodic law. Periodic law. Number two, everyone should understand the concept of groups and periods. Everyone should understand what? The concept of groups and periods. Okay. So the next is, given the electronic configuration or the electronic arrangement of an atom, we should be able to tell the group and the period the element belongs to. If you are given the electronic configuration of an atom, you should be able to tell the group and the period that the element belongs to. So if you have taken this down, unmute yourself and say I.
I.
Unmute yourself and say I, so that I will know.
Hi.
Good. Ada, are you with us? I'm still not hearing Ada. Okay. Let's continue. Okay. In 1869, a Russian chemist, you may have heard the name Mendeleev before, but today you have the privilege of seeing the full name, Dmitry Ivanovich Mendeleev. Nobody's going to ask you the full name, but it's very important for memory's sake to try to remember the name, okay? Dmitry Ivanovich Mendeleev. He arranged the then discovered elements in order of their atomic mass. Now, I want you to take note of something. We said the then discovered elements. Can you still see my screen?
No.
No, sir.
Okay, pardon me on that, please. Don't mind me, I tapped on something and it removed the share. Okay, so I'm sharing back. I'm sure you can see it now.
Yes.
Good, let me make it appear better. So, that's what I was saying. I want you to pay attention to this term. I said a Russian chemist arranged the then discovered, the elements that were discovered at that time. Not every element, not all the elements that are known now were discovered at that time. There were very few that were discovered. Are we together? There were very few that were discovered. And what did he do? He arranged them in their order of atomic masses. Another thing to note there. In order of atomic masses. Atomic masses. Do you know what atomic masses is? There's a difference between atomic mass and atomic number. Who can tell me, please? Difference between atomic masses and atomic number. Anybody? Eko Kamsi. Eko Kamsi, unmute your microphone.
Mass.
Yeah.
Atomic mass is total number of neutron and proton, while atomic number is total number of proton.
Beautiful. Beautiful. That is absolutely correct. Atomic mass is the sum total of protons and neutrons in the nucleus of an atom, while atomic number is just the number of protons. So Mendeleev used atomic masses at the point to arrange elements. There were some faults in his arrangement, okay? Some faults were found with his arrangement. Now, what did he discover? He discovered that elements with similar chemical properties were recurring at regular intervals. Are we together? Elements with similar chemical properties were recurring at regular intervals. Okay? If we look at elements like lithium, lithium is Li, beryllium, boron, don't mind me, I'm using my hand, I'm not using my stylus. Carbon, nitrogen, oxygen, fluorine, neon. As we are sharing this slide with you, fluorine, neon, sorry, that. As we are sharing these slides with you, you can be jotting down a thing or two. Okay, then after neon, we have what? Sodium. After sodium, we have magnesium. Now, one very important thing he discovered when he arranged elements in this order is that when he picks an element, let's say lithium, we are picking lithium now. The 8th element after lithium will have similar chemical properties as lithium. Which element is the 8th element after lithium? Unmute yourself. Nobody knows. It's already on the board. It's already on your screen. We have beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, and magnesium. Which one is the number 8 after lithium?
Sodium.
Sodium. Very good. That is sodium right there. Now, Mendeleev discovered that lithium and sodium were reacting in the same way. And he was like, wow, let me try the next element after lithium, beryllium. He noticed that beryllium and magnesium were acting in the same manner. Boron and aluminium had similar behaviors. Carbon and silicon had similar behaviors. And he decided to arrange all these elements in what we call the periodic table. The periodic table he had at that time was not as refined as what we have now. Are we together? It's not as refined as what we have now. This is the gentleman. This is Mendeleev that did the great work that we are enjoying today in the field of chemistry. Okay? Remember, I told you that at the time he was making these discoveries and trying to arrange elements in groups and periods, many elements were not discovered at that time. In fact, noble gases had not been discovered. Please, I didn't say they were not in existence. I meant they had not been discovered, because I have seen students interchange discovered and existing. Okay? They are not the same thing. They are not the same thing. All right? Discovered element and existing element, and an element might be in existence but had not been discovered yet. So the noble gases were not discovered at the time. So he arranged them into groups, the ones that were discovered at that time. Are we together? Now, based on the recurring chemical behaviors he had discovered, he predicted the properties of the elements that will occupy the spaces he left. Now, this is a very wonderful thing he did, because he noticed that the elements that he arranged in one group had similar properties. Every element in every group, the way he arranged them, had similar properties. But there were some gaps in his periodic table, elements that had not been discovered. He didn't know what these elements were, but he was able to predict that any element that will be found to fit into this position will have the same or similar properties as the elements that are already discovered. So there were gaps in his table, but these gaps were eventually filled. The elements were discovered, and up to 85% accurate, what he predicted were found with these elements. So all those predictions he made about these elements, that they will do this, they will react with water, no, they will not react with water, they will do all those predictions he made, up to 85% accuracy was found. Are we together? So at that time, elements were discovered and they were fitting into the periodic table. As more elements were discovered, errors, small errors were also discovered. And I'm going to mention one of those errors as we proceed. Now, the modern periodic table is a modified version of Mendeleev's work. Remember, Mendeleev arranged elements according to their atomic masses. He was arranging them according to their atomic masses. But modern work, other scientists did some work to modify it because he encountered some problems. Let's look at some of the problems he encountered. Who can tell me the relative atomic mass of, which one should I use? Chlorine. Who can tell me the relative atomic mass of chlorine? Okay, you're going to get used to this with time. 35.5. The relative atomic mass of, after chlorine, we have argon on the modern periodic table. Are we together? We have argon. Relative atomic mass of argon, 40. Then after argon, the next period, we have potassium. Then after potassium, we have calcium. Now I want you to notice something. The relative atomic mass of potassium is 39. Are we together? Instead of the relative atomic mass to increase from argon, maybe from 40 to 41, it decreased to 39. That was an anomaly. This is just one example. Are we together? Then after potassium, in calcium, we now have 40. Did you notice something? 35, 40, then it decreased to 39, then went back to 40 again. That created some discrepancy. I'm just showing you one. There were so many of them that were found like that. But some other people, including Muesli, actually did extra work on the periodic table. And they said, rather than using the atomic mass, let us use the atomic numbers. The atomic number of chlorine is 17. That of argon is 18. That of potassium is 19. And calcium is 20. So instead of using atomic masses, the modern periodic table used atomic numbers. So if you are asked to state the periodic law, okay, the periodic law states that the properties of elements in the periodic table is a function of their atomic numbers, not atomic masses. Okay, atomic masses is for the old periodic table. But does that mean we should abolish Mendeleev's periodic table? No. Most of his predictions stood true. Many of the elements he found had the properties as they should have. They were sharing the same properties. That's the elements he put in the same group. They were sharing the same properties. Are we together? So what happened was just modification of his periodic law. Now, I want somebody to read me this periodic law. Let me call on somebody. Ada Ozagu would have not been hearing her voice. Ada Ozagu, let me hear you now. I can't hear you. Okay, Ada Ozagu, it looks like you have a problem with your microphone, I heard. Okay. But I'll need please try and fix it too. The beauty of this class is that microphone, So try, So Samuel, Samuel, unmute yourself. Very good. Samuel, can you read the modern periodic law? Samuel, I can't hear you. Samuel, I can't hear you. I can't hear you, Samuel. What is happening? What is happening? Okay. Opera Brian, unmute yourself. Samuel, I don't know why I can't hear you. Opera Brian, unmute yourself. Opera Brian, can you read the periodic law?
The modern periodic law states that the properties of the elements are a periodic function of their atomic numbers.
Okay, thank you very much. That is very good. That is very good. That is very good. The modern periodic law states that the properties of the elements are a periodic function of their atomic numbers. Okay? No. Okay, just give me a moment. Let me sort something. Yeah, I hope everybody can hear me now. Sorry about that. I was trying to sort an issue back there. Okay, so the model periodic law says that the properties of elements are a periodic function of the atomic numbers. Basically, forget about the big grammar. What it simply means is that elements are now arranged based on their atomic numbers only, not atomic masses. Is that clear? So this is the periodic table. This is the periodic table. All right. And if you can screenshot this and keep it with you, because we'll be looking at it again and again. You can see the elements the way they are arranged. Later on, we are going to talk about groups and periods. You are going to see these elements, all these elements. You can see 1A here. These elements are group 1 elements, and all of them have similar properties. These elements here are group 8 elements. They are all noble gases and they have similar chemical properties. Are we together? They have similar chemical properties. So let's clear this. Oh, sorry. Now, we are going to look at, on the periodic table, we are going to look at metals, non-metals, and metalloids. Metals, non-metals, and metalloids. Now, metalloids simply means semi-metals. I'm sure when you were in JSS3, you heard of semi-metals, or maybe they were still called metalloids. It's the same thing. They are used interchangeably. So metals constitute the larger portion of the periodic table. As you can see, the metals are those that are blue. Are those that are blue. Can you see it? It's very massive. That's up to 85%, if not more than 85% of the periodic table made up of metals. Then the non-metals are yellow. They are on the right side, okay? They're on the right side of the periodic table. You can see them there from carbon down, phosphorus, selenium, iodine, radon. All these are non-metals, okay? Then you will see a zigzag pattern demarcating the metals from non-metals. That zigzag pattern is where you will find the elements that share some properties of metals and properties of non-metals. Are we together? Properties of metals and properties of non-metals. So the most common one that you cannot afford to forget at your level is silicon. Silicon, okay? Silicon, you cannot afford to forget silicon. Silicon is the most common metalloid or semi-metal that is known. So I'm going to pause here for a while, then I will allow you to ask questions. So right now you are free to ask questions. If you want to ask a question, I've taught you how to raise up your hand, isn't it? So if I don't see any hand in the next maybe 2 minutes, 60 seconds, we will continue. But while we are at that, make sure you are writing what is on your screen. No questions? That means everybody is following. You can see right there on the periodic table where we have metals, non-metals, and metalloids. Metals, non-metals, and metalloids. So let us continue since there are no questions. So we'll clear this. Now, you can see from the periodic table below that metals constitute over 85% of the left side, non-metals to the right, and the metalloids make up a zigzag pattern separating metals from non-metals. Okay, so that has been explained earlier. So we are going to look at groups and periods. Groups and periods. What are these groups and periods? The vertical columns of the periodic table are known as groups. Take note of that. The vertical columns. You know what I mean by vertical? Huh? Upright. The vertical columns are known as groups, while the horizontal rows are known as periods. But we are going to be talking about groups for now. Samuel. Samuel, can you hear me now? Okay, I still can't hear Samuel. I don't know what the problem is. Okay, Chibueze Chikamso, can you unmute yourself, Chibueze? Chibueze. Chibueze, unmute yourself. Okay, I want you to read that paragraph there. Each group contains, go on from there.
Each group contains elements with
Okay, we can't hear you now. We can't hear you. We can't hear you, Chibueze. Can you hear me? We can't hear you. Oh, no. Chibueze has problem with his microphone. With his network, rather. Okay. It's network. It's network. Okay. Victory. Victory, are you there? Victory, unmute yourself. Victory. Victory, read. Each group, go on.
Each group contains elements with the same number of valence electrons. Electrons in the outermost shell.
Hold on there.
Group number
Hold on there. Victory. You just read that each group contains elements with the same number of electrons. Valence electrons. That's electrons in their outermost shell. Do you understand what we mean by electrons in the outermost shell? I'm asking you directly, Victory. Can you hear me?
No.
Okay. Have you seen
Yes,
this?
sir.
Okay, let me show you this. You have seen this atomic model before. They'll say this is the nucleus. Then the first shell has 2 electrons. Have you seen something like this before? Then the second shell.
Yes, sir.
They'll tell you the second shell has so number of electrons. 8 electrons, isn't it?
Yes, sir.
Then the third shell. Now, the outermost one is now this one. Assuming this is the element we are dealing with. How many shells can you see there? Victory, are you there? Okay, everybody unmute your microphone. Everybody unmute your microphone. Everybody unmute your microphone. Okay, Kamsi, can you tell us how many shells you can see there?
3.
3 shells, isn't it? We have this one and we have this smaller one inside. Now, when we talk about valence shell, we are talking about this one outside here. I'm going to coat it with blue. This bigger shell here now outside is the valence shell. Okay? So what we are saying here is that the number of electrons on this valence shell, assuming this is an electron, 1, this is another electron, 2, this is another electron, 3. If we have 3 electrons on the valence shell, it has already told us from this structure that this element is in group 3. Hello? I hope everybody understands. That's why I'm saying you should unmute your microphone
Yes,
so that you can
sir.
speak if you do not understand. Okay? 3 electrons in the valence shell means that that element is in group 3. It's as simple as that. Okay? That's what the groups will do for you. So, oh, sorry, let me. Okay, I want to call on somebody else to read for us. But let me go on. The group number indicates the number of valence electrons. I hope you can see that. What that means is that group 1 elements have 1 electron in their valence shell. If you see an atom that has only 1 electron in its valence shell, feel free to categorize it as a group 1 element. Remember, I said an atom, not an ion. No. An atom is one that has not lost or gained electron. It is still neutral. Okay? So it has only 1 electron in its valence shell, then it is in group 1. If it has 2 electrons in its valence shell, it is in group 2. If it has 7 electrons in its valence shell, it is in group 7. Okay? And so on and so forth. There are 7 groups. Okay? There are 7 groups, as you can see here. So look at the ones in pink. Check out the ones in pink.
Yes, ma'am.
Are you seeing the ones in pink?
I know.
Just a moment. Let me minimize this.
Oh, go. With this episode. Says join English class.
Yeah, the one in pink represents all the elements in group 1. Lithium, sodium, potassium, rubidium, cesium, and francium. Please, you can mute yourselves now. Mute yourselves. Mute yourselves quickly. Thank you very much. Then the elements in group 2 are beryllium, magnesium, calcium, strontium, barium, and radon, and so on and so forth. If you go to group 7, you have fluorine, chlorine, bromine, iodine, astatine, tellurium, and so on and so forth. Is that clear? So any element, the group of the elements will tell you the number of valence electrons. If you know the valence electrons, you can categorize the group. Is that clear for everyone now? I hope everybody understands that. That's it. Now I want you to pay attention and see that hydrogen is not in any group. Hydrogen is not particularly placed in any group. And later on, I'm going to give you an assignment on that. When we get there, I will show you the assignment. You are going to find out why hydrogen is not placed in any particular group. In some periodic tables, like the one I showed earlier, you are going to see hydrogen placed here. Okay? But that placing hydrogen there is only for convenience. It's only for convenience. Okay? You later realize that it doesn't even fit into that place perfectly. There are other groups it can still fit into. So it's going to be part of your assignment. I'm not going to let out everything now. I won't let out everything now. So, group 1 elements are also called the alkali metals. Please take note of that. Take note of that. If they ask you, which element or what group of the periodic table contain the alkali metals, you should be able to state it. I said alkali metals are in group 1. And those in group 1 include lithium, sodium, potassium, rubidium, cesium, and francium. Is that clear? Those in group 2, look at the names are related, and sometimes exam bodies will just trick you. Once you hear alkaline metals or alkaline earth metals, we are referring to group 2. So while group 1 are called alkali metals, group 2 elements are called alkaline earth metals. Alkaline earth metals. I hope that is clear. So we are going to take the remaining. Group 3, they do not have any special name. Group 3 have no special name at all. Okay? Group 4 have no special name. Group 5 have no special name. Group 6 are called chalcogens. Group 6 are called chalcogens, but I also need you to, well, you may not bother yourself so much because it's not, you are not required at this level to know the name of group 6 elements, but I just mentioned it for some of us or some of you that might be writing some international exams later in the year or next year. Okay, just remember that group 6 elements are called chalcogens. Then group 7 elements are called halogens. Then group 8 elements are the same as group 0. It's either group 8 or group 0, and they are called noble gases or rare gases. Noble gases, rare gases, inert gases, okay? But they are generally called noble gases. Are we together? Good. Now, I want you to notice something again. This is your assignment. Write it down. You have 2 minutes. Notice that hydrogen is not placed in any group in the periodic table above. Give detailed explanation as to why hydrogen is not placed in any group of the periodic table. Now, this is an assignment. When you finish the assignment, you are not doing the assignment this night. I'm going to give you the task for this night. I know many of you are wondering why you didn't get your results for yesterday's assessment. You will still get it. You still get the result for yesterday's assessment, but I'm going to give you another one for this night. Okay? I'll give you another one for this night, so pay close attention. But this is an assignment that you must submit. Today is Tuesday. You must submit this assignment before Friday. That means you have tomorrow, Wednesday, and next tomorrow, Thursday, to do your research from different sources. Do your research from different sources. If you go to ChatGPT and you bring up an answer, I will know this is machine language, not machine language per se. I will know this is machine response rather. So it's not bad. You can go to ChatGPT, but still search your textbooks, especially your textbook. Especially your textbook. I will appreciate it if you give me a response from your textbook. Then you can read other sources, other materials that will help you understand that explanation clearly. All right? So that is your assignment. I believe you have all copied that. Now let's talk about periods. We talked about,
Sir.
yes. Go on, I can hear you. Who is speaking?
When are we going to submit the assignment?
Sorry?
Chikamso.
Chikamso, yeah?
When are we supposed to submit the assignment?
I said you are submitting before Thursday.
When are we supposed to submit the assignment?
Before Thursday, before Thursday, before Thursday. Okay, I'll still announce it on the platform. You are submitting your assignment before Thursday. Okay? So, periods. Now, the horizontal rows of elements in the periodic table make up the periods. The horizontal rows, that's moving from left to right, okay, across. across like this make up the periods. There are 7 periods in the periodic table. The elements in a period have the same number of shells. Now, take note of that. Key information. Key information. The elements in a period have the same number of shells. So I'm going to draw an atom. This is the nucleus. Okay. So I'm going to draw an atom. Then this is 2, 3, 4. Don't mind the beauty of my atom. This is a 21st century atom. So 1, 2, 3, 4, 5. Now I'm going to call on somebody. I'm going to call on somebody. Oh no. Oh, sorry. Let me share again. Let me share again. Sorry, I think I wiped off my atom. I'm going to draw it again. Let me draw it here. 1, 2, 3. Okay, so I'm ignoring the shells inside. Let me focus on the one outside. 1, 2, 3, 4, 5. So the nucleus, this whole, okay, the nucleus is the center. So there are 3 shells here and there are 5 valence electrons. I want somebody to tell me the group and the period that this element will belong to. Unmute yourself if you know. The group and the period the elements will belong to. No idea? Nobody? Nobody? Adozagu. Okay. The group and the period. Adozagu is raising up her hand, but she's not saying anything, so there's no way I can hear you. Victory. Okay, Samuel, can you unmute yourself and speak now?
The element belongs to group 5.
Group 5, beautiful. Excellent.
And period 3.
Period 3, very good. Very good. Now you understand what I mean. Group 5, period 3. Very good. We are going to play a small game shortly. We are going to play a small game shortly, so everybody pay attention so you don't miss out on this one. All right? So let me clear this. So the elements in blue, notice this, the elements in blue between groups 2 and 3 above are called transition elements. Transition elements, or rather, they are called D block elements. Later on, we are going to refine this statement because not all D block elements are transition elements. Later on, we are going to refine that statement. They are not all transition elements, but they are all D block elements. So the blue I'm talking about is this region. Let me use red. This region here. Okay. When we are talking about groups, we don't include them. For now, at your level, we will not include them. That's why you see that there's group 1 here, there's group 2 here. Then we jumped all that region to get to group 3, 4, 5, 6, 7, and 0. Is that clear? So their groupings are separate and different from the ones discussed here. Transition elements will be discussed much later. You're going to do transition elements most likely in SS3. But if you stay with us, we'll probably finish SS3 work before the end of your SS2. Okay, so let's look at this now. Let's look at this. Let's clear this. Game time. Game time. How many of you screenshot the periodic table I said you should screenshot? I asked you earlier to screenshot the periodic table. How many of you did it? This is where you will need it. This is where you will need it. Okay, I'm looking at the charts. I'm looking at the charts now. Who can name the elements in period 7, group 1? Just send a chart. Send a chart. Period 7, group 1. Let's see who the first person to get it would be. Okay. If you didn't get the periodic table, Francium, very good. Echo Kamsi got it. Francium, very good. Francium, group 7, sorry, period 7, group 1. Then the next one, period 3, group 5. Period 3, group 5. Period 3, group 5. Echo Kamsi has gotten it again. Are you sure the others are listening to me? Echo Kamsi, you have filled your slot for today. You have filled your slots for today. Okay? You can only give others moral support. Yeah? You can only give others moral support. I hope the others are even hearing me. Period 1, group 0. Period 1, group 0. Echo Kamsi, you are not part of it again. Period 1, group 0. Anybody? Helium. Wonderful. Very good. Very good. That's from Onka Carlos Samuel. Beautiful. 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 Then next, period 3, group 2. Period 3, group 2. I want to get the first. First person. Period 3, group 2. First person, check. Period 3, group 2. No. Victory skipped the first period. Magnesium is correct. Magnesium is correct. Victory, did you see where your error is? Victory, can I hear your voice? Did you see where your error is?
Yes, sir.
Good. You skipped that fourth period. That one that has hydrogen in it. You skipped it. Okay, you skipped it. That's the problem there. All right. Then the next one is period 2, group 7. Group 7. Samuel, no. Period 2, period 3, rather. Sorry, what am I saying? Period 2, group 7. Period 2, group 7. Fluorine, that's correct. You too, you have filled your slot for today. You have filled your slot for today. Okay? Period 2, group 7. All right, let's go to the next one. So, Onka, Kalu, you take a break. You and Echo Kamsi. So, let's hear from the others now. Let's play a little period group game. Mention one use of the element in, okay, I'll make it open again. I'll make it open again. But first, you are going to identify the elements. Then you tell me its use. Okay, you tell me its use. So group 3, period 3. Which element is in group 3, period 3? You name the element, then you state one use of the element. Hello? Nobody. This one is open to everybody now. It's open to everybody. Group 3, period 3. Beautiful. Echo Kamsi gave us one. Aluminium for making cooking utensils. Very good. Aluminium is in group 3, period 3, and it is used for making cooking utensils. Very good. Very good. How many of you know that aeroplane body is actually made with aluminium? Aeroplane body is made with aluminium, and that's because aluminium is light as compared to iron. If iron was used to make aeroplane body, the problem with that is the weight. The weight would be so much, and it might overwork the engine, and the engines might not be able to fly it properly. Then let's go look at group 6, period 3. Group 6, period 3. Sulfur. I agree. Samuel, I agree. Sulfur. Do you know any use of sulfur? Any use of sulfur? Beautiful. Beautiful. Sulfur is mixed with nitrates, potassium nitrates, and sometimes charcoal, all right, to make gunpowder. To make gunpowder. So that's also how matchsticks are made, all right? It's used for making matchsticks. Sulfur is also used for making tetraoxosulfate 6 acid. It's also used to make a whole lot of drugs, okay? Sulfur containing drugs, okay? It is also used in making some antifungal medicines, okay? Especially those ones that are used for anti-dandruff, right? Some of these anti-dandruff, one very important example is sulfur 8. Sulfur 8 is an anti-dandruff, and it is used, is made of sulfur and some other ingredients. Very good. Now, quickly mention the group and period of the element we breathe in from air. The elements that our lungs take when we breathe in from air. Mention the group and period. Find it, find it, find it. Oxygen, group 6, period 2. That's from Samuel. That's from Samuel. Very good. This one I'm having only Samuel and Kamsi responding today. The others, what is happening? Are you sure they are still here? Huh? Where are the others? Victory, I'm not hearing you. Opara Brian, I'm not hearing you. Udebuni Chinyere, it's like your network is giving you trouble. You've been going in and out. Try to get a place where you have a good network, all right? Yeah, get good network. Okay, very good. Oxygen is in group 6. Group 6, period 2. Okay, oh, very good, Chinyere. Oxygen in group 6 and period 2. Very, very good. Now, next, Mention the group and period of the element that makes up 78% of air. 78% of Kamsi. It's like you typed it and you were waiting for. Very good. Nitrogen is in group 5, period 2. Very good. Very good. Now, Kamsi, let me ask you, tell me how many shells, how many electron shells does, and how many valence electrons does nitrogen have? Unmute yourself. Yeah?
Okay. It has 5 valence electrons and 2 shells.
Very good. Very good. Excellent. Kamsi has, sorry, I said Kamsi has 5 valence electrons. Nitrogen has, don't mind me there. Nitrogen has 5 valence electrons and 2 shells. The first shell, which is the smaller shell, has only 2 electrons. Then the bigger shell outside that one, which is the L shell, has 5 electrons. That's its valence electrons. Okay, the last one. Mention the group and period of the element that strengthens bones and teeth. Kamsi, don't type anything here. Opera Brian, finally. Opera Brian. Good. Oka Kalu Samuel. Oka Kalu Samuel. You got relegation. Eh? You take small break. Very good. Calcium is in group 2 and period 4. Group 2 and period 4. Now, Opera Brian, I don't know if your microphone is okay. If it's okay, you can unmute it and tell me. But if it's not okay, feel free to type it. Okay? Yeah, Chibueze Chikamsu, very good. Chibueze Chikamsu, very good. Group 2, period 4, very good. You are all winners in this game. You are all winners in this game. Okay, okay, Chikamsu, at some point you went out. So I want you to answer this question. I want to be sure that you got this clearly. Now, nobody should type anything on the chat. Nobody. Just Chikamsu. Chikamsu, I want you to tell me that calcium that is in group 2 and period 4, how many valence electrons does it have and how many shells does it have? Feel free to type it. We are waiting. Yes. Let's be patient with Chibueze. Chibueze, I hope you are typing. I hope you are typing. Okay, Chibueze is not. Okay. Beautiful. Beautiful, Chibueze. 2 valence electrons and 4 shells. Excellent. Excellent. You got that right. You got that right. Very good. Very good. So we are going to look at blocks. We are going to look at blocks of the periodic table. Okay. Escape from here. Okay. Sorry. Let me send it back again. To share this. Can you see what I'm sharing? Hello. Let me move this out.
Yes, sir.
Yes.
Good. Now, Chinyere, I want you to read what you can see.
Blocks of the periodic table. Based
Okay.
on the electronic configuration of elements,
Uh-huh.
the periodic table is also divided into blocks. These
Okay.
blocks correspond to the element's highest energy level or subshells S, P, D, and F. The elements with the S subshell as their highest.
Sorry. Don't mind me. Don't mind me there. Can you see it now?
Yes,
Good. Go on.
as their highest energy level are in the S block,
Okay.
while those with the highest energy level in P subshell are in the P block. The
Okay.
D block contains special kind of metals called transition metals,
Good.
while the F block contains the inner transition metals, which are the
You can't
Where's
see
my
it?
glasses? Yeah.
You don't have your glasses. Okay. Okay. Now you have done well. Okay. So these blocks, let me show us the blocks. We can see the blocks here. We have the S block, as you can see there. We have the D block. We have the P block. And we have the F block. Now, these elements in the S block, you can see that S block is for groups 1 and 2 only. S block, group 1 and 2 only. Okay? Then if you go to the P block, it is from group 3 to group 8. Groups 3, 4, 5, 6, 7, 8. They are all in the P block, as you can see there. Then the D block is a special kind of elements that I said we are going to discuss later. They are metals, but they are specially transition metals. They are called transition metals. They have some interesting properties that we'll be discussing later on, maybe towards the end of your SS2 or in SS3. Okay? Then the F block is what we call the inner transition metals. I wanted to zoom in so that you can see that the F block is actually embedded. It's supposed to be embedded inside the somewhere inside the D block. Okay, but for convenience, of course, if you put it there, the periodic table will look so distorted and so complicated. So it is kept out here. All right. So the F block is called inner transition elements. Is that one clear? Is that one clear?
Yes, sir.
Okay. As we round up, I want everybody to unmute themselves now. I want you to unmute yourselves.
Okay.
Okay. If there's noise in your background, feel free to mute yourself, okay? If there's noise in your background, feel free to mute yourself. So I'm going to ask some questions and I want to see responses. Are we ready? Are we ready? Question number 1.
Yes.
Question number 1. Who can state the periodic law? The modern periodic law.
Elements are arranged in the periodic table by increasing relative amount atomic mass.
No. Not exactly. We are talking about the
The
modern.
periodic
Okay.
The periodic law states that the properties of the elements are a periodic function of the atomic numbers.
Very good. Atomic numbers, not relative atomic masses. Are we together? Remember, I told you that is the modification of the Mendeleev's periodic table, isn't it? That's the modification. Okay. Another question. Another question.
What are you answering?
Lithium is an element in group 1. What do we call group 1 elements? Don't answer. Don't answer. Don't answer. Don't answer. Don't answer. If I call your name, you answer. Nobody should say a word. If I call your name, you answer. Let me bring out my lists. Opera Brian. Opera Brian, is your microphone okay today?
Yes.
Okay, Opera Brian, can you answer the question?
Alkali metals.
Alkali metals, very good. Very good. Excellent. In fact, everybody start throwing your tada. Yesterday, I taught you how to throw tada. Oh, yeah. Go and look for it. I'll see soon. Very good. Chinyere. Very good. Very good. This tada is for all of you, all those that have been answering questions. Very good. Now, next question. Next question. This question will be answered by Ada Ozago. Ada Ozago, I understand that your microphone is having issues, but I want you to type this. I want you to type your answer.
No problem, Commander.
Chlorine is a halogen. Chlorine is a halogen. Which group of the periodic table contains the halogens? So type your answer. Which group of the periodic table contains the halogens? I hope she can hear me. Ada? Uh-oh, Ada has gone off. Ada, can you hear me? Which group of the periodic table contains the halogens? Just type your answer in the chat. Don't worry, with time, you all learn how to use these tools. And when I call your name, before I finish calling your name, you just deliver your answer. Ada is not responding still. Okay, let's call somebody else. Let's call somebody else. Okay, Chibueze Chikamso.
Okay.
Chibueze Chikamso. Chibueze Chikamso.
Group 7.
Group 7. Very good, Chibueze. Group 7. Very good. Excellent. Oh yeah, everybody. Tada! I'm counting you. If I don't see your own, you are not present. Very good. Very good. Very good. Chibueze and all those that answered, this is for you. Very good. Very good. Okay. Okay. So now this is your turn. It's now your turn to ask questions. Feel free to type your questions on the chat. Okay? Feel free to type your questions on the chat. If you want to use the microphone, please raise up your hand so that I'll invite you to speak. So, question time. Question time. Raise up your hand. I've taught you how to use it. If you want to use the chat, go ahead and use the chat. So we have few minutes till we close. We have about 2 minutes or so till we close. Nobody's asking any question. Nobody has any question. So you understood everything I explained today. Is that what you are trying to say? Everything is clear. Okay. Okay. I'll send you questions now. I'll send you questions. Okay. Somebody is asking, what is a functional group? Functional group. Now, functional group is a term used mainly in organic chemistry, okay? In organic chemistry for organic compounds. Now, a functional group is an atom, a group of atoms, or a type of bond that determines the chemical property of a compound. So what I mean is, the functional group is the active site, let's put it that way, the active site of an organic compound. That part of that compound is what determines how it reacts chemically. All right. So you are also going to do functional group towards the end of SS2 or the beginning of SS3. Functional group. Yeah. So questions? Echo Kamsi, go on, unmute yourself, please.
Sir, please, in some periodic tables, I've
Yeah.
seen hydrogen under group 1.
Yes, I said it, I mentioned it earlier that hydrogen is placed in group 1 just for convenience. But if you go through this research I asked you to travel through, you're going to see that there is a reason why it can't fit, it doesn't fit perfectly in group 1. There's a reason why it was removed from group 1. Now, I'm still sharing my screen. I want to show you something. Now, let me just give you one instance. I'll just give you an instance. Let me move this. Now, look at this. Can you see this? Metals, metalloids, and non-metals. Can you see that? If you look at that, you see that hydrogen is still in group 1, isn't it? But does it look like the group 1 elements? Aha. Now you understand what I mean. It's entirely different. It's just like one black, how will I put it? One black fowl among white fowls. Okay, it's just different there. So it is placed there just for convenience. But as you can see, I've already given you one expo. There is one thing that disqualifies it from being there. But as it is disqualified from being there, it fits almost perfectly in another group. I'm not going to tell you the group. Okay? It fits almost perfectly in another group. Eko Kamsi, I hope I've answered your question.
Yes, sir. Thank you, sir.
Good. You're welcome. So questions. This is question time. We are rounding up. Question time. It's not when my question comes. Anyway, you'll not see me to ask now. When I'll send my hot questions now, they start looking for me to ask questions. Go through what we have done today and see. So I'm also going to, later on, like I said, I'm going to send you a link to join the Google Classroom, okay? So that you can see your notes, the videos for your classes, and what do we call it now? Your notes, the videos for your classes, and quiz. Most of those things will be sent there, okay? You will easily find them from there. Okay, so in the absence of any other question, I'm going to call on the students in the other room so that we'll close for today. Again, please, you can see for some of you that came late. Okay, let me just address this matter with everybody when they come in. So give me a moment. So let's stop share. Go to the breakout rooms. Okay. Wow. Yeah, let me make a broadcast. Okay, sorry, this is Uncle Celestine. Our time is up. Start rounding up from the breakout room. Start rounding up quickly so that we can come back to the main room and close for the day. Thank you. Okay. Okay, good evening, students. Is everybody back to the main room? Auntie Gochinyere, are we all back to the main room now? Okay. Okay. Ugoma, are you in the main room now or you are still in your breakout room? Okay, that means they are still in their breakout rooms. Those of you that are here, just wait a minute. Wait a minute. I'll soon address all of you, then we close for the night. Okay, let's come back to the main room now. Let's come back to the main room now. In 30 seconds, I'll be closing the breakout room. Make that 60 seconds. 60 seconds. I'll close the breakout room. Everybody will come back to the main room. Thank you. Okay. While we are waiting for them to come back to the main room, asking of questions is still available to you. Okay. The breakout room will close by itself in 54 seconds. So, okay. 30 more seconds. 30 more seconds. I think the teacher is still, okay, I will join their room and see. What do you want? They're waiting for me? Okay. Okay. I didn't know. Okay. 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 We'll be returning now. Okay. I want to assume everybody is in the main room now. I hope we had a fruitful class today. I want to quickly address some issues that you might be having with the online class, okay? And these things are going to get better as soon as you do something about them. The biggest issues you'll be having is network, all right? The biggest issue is network. So try to see that you are using, like I said yesterday, try to see that you are using a network that is stronger around where you live for browsing, not for calls, for browsing, okay? If one network is not very good, you may want to get SIM for another network. SIM is not very expensive now, or if you can afford it, you get a Wi-Fi or a MiFi, or you connect to this optical fiber network that MTN is installing now, okay? You can make inquiries on that one. That one usually is so fast, so fast. Okay, make inquiries on that one, get them installed, and you wouldn't need to be buying data anymore as long as you are within 100 meters of your Wi-Fi there. Okay, that's number one. Then number two, most of us tried today, but we still had a little late coming. And because of that late coming, we are going to start addressing class issues by 6:45. Okay, I really want our classes to start by 7 on the dot. We work with time. So we'll start addressing class issues by 6:45. So if you come in by 6:45 and there is any issue, if you call me, I can pick. If you call the moderator, she can pick. You understand? If you call any of the staff, they will pick and they'll be able to respond. But you see, when I start teaching like this now, no matter how you call me, I'm not going to pick the call. I will not pick the call because I'm already teaching, okay? And when I keep picking calls, it will distract the class. So don't even bother calling me once it is 7 p.m. So to make it better for you now, classes will start by 7, but you can log in by 6:45. So if you have an issue within that 15 minutes, we can address it. In fact, within that 15 minutes, I can even be answering whatever question any student has that is outside what they are learning, as long as it's associated to, with my subject too. So you will have your own, what do we call it now? You have time to set up whatever issue you have. If we are able to help you fix 1 or 2, and you're already in class, good. So that when class starts by 7, you will know that class has started, and we cannot address some of these issues from 7 p.m. Class starts by 7 on the dot and ends by 8:30. So you should be expecting your exit quiz. For those in SS2, you should be expecting your exit quiz. I'm going to put it on WhatsApp. Yeah, you're going to see it on WhatsApp shortly, but I'm going to work on it because we didn't finish the entire topic, but the exit quiz might be for the entire topic. So I'm going to remove the ones that are for the one we'll treat in the next class. Then I'll send it to you. Okay, so be patient. Just start going through your jottings. In the next 15 minutes, 10-15 minutes, you're going to see your exit quiz. And remember, as a rule, if I send your exit quiz, you must answer it today, not tomorrow. If you send your own tomorrow, I will not respond. You must answer it today. So carry your chemistry textbook. You all have your chemistry textbook. Start reading the periodic table. For those that did English, you have your English textbook. you have some materials that some notes you picked from today's class. Start going through them. If your auntie has sent you your exit quiz, start working on it. If she hasn't, give her some time. You'll still get it online. So I saw somebody raise up their hand, but I think the hand has disappeared. Probably I've answered the question he or she wanted to ask. But if you have any question real quick before we close, raise up your hand, please. 30 seconds. Okay. I don't think we have any problem. So start going through your jottings. Your exit quiz will come in shortly. May the Lord bless you and keep you. Have a blessed day, and God bless you all. Bye. See ya. Yeah, thank you. Thank you. Thank you.
Mr. Celestine, do you have like a minute when they are logged out, please? I want to talk with you.
Yeah, it's okay. It's okay. Okay. Yeah, para Brian, thank you. Thank you. Thank you, Brian. Thanks so much. Okay. Okay, Chinyere, I think I will end the meeting, then we talk on phone if that is okay. Because if I wait for them, some of them are still enjoying the class. They don't want to go. So I hope it's okay at Chinyere, or you want it to be on Zoom. Just let me know.
No, we can talk on phone. It's okay.
Okay, great then. God bless you all. Bye.